Hello, my name is Alan Pickering. I'm doing a very short video on the two engines that I made during lockdown. I'm taking them on show tomorrow to Sammy Millers Motorcycle Museum in New Milton. I'm just checking it out, make sure that everything works. This one here is a water-cooled Robinson layout of my own design, and this is what it looks like. The advantage of this one is this vertical link working the displacer cylinder. It goes up and down virtually 100% square, a bit like what's parallel motion. This is the water. Not that you can see it, much of it. And this is a water pump. And the idea behind this water pump was that the water at the bottom of this cooling tower here was always cold, and the water at the top was quite warm because heat rises. This little setup here is what you have to keep cool. That's your displacer cylinder area, and it's full of water, and the idea is to have water circulating into this water tower here, and hopefully everything will stay cool. In practice it worked fine, but the top half got hot and the bottom half remained cold. The thermic siphon system didn't seem to function too well, so I decided to put a little water pump on there, pump the water from the bottom round and feed it into here. And the whole thing circulates quite happily now, and the bottom of this cylinder and the top of the cylinder are the same temperature, which after 2 hours of running is cool enough to hold your fingers in. This is a smashing little design, I think. It's a smooth as silk, and it is dead quiet. Let me turn the lane down a bit. Doesn't need too much air. The only noise you hear is from the burner. Turn that down a bit. Just working my way around it. For those who've never built them, these engines are quite difficult to make. They've got to be 100% perfect, otherwise they won't run. There's not a lot of power in them. Heat is transferred into rotary motion in one operation. No boilers, no water to boil. They are quite magical, the fact that they work at all. I consider you need water cooling, otherwise the whole lot just gets so warm it stops through saturation. It's the difference between hot and cold in the engine that makes it work. If everything's the same temperature, they don't work. This other one here, again, is my own design, made out of scrap. They're all made out of scrap. through yet in it. There'll be something to do in the lockdown period. This cylinder here is the thing that matters. It's made of stainless steel, and it's a stainless steel sugar basin, which I favour. And that's a heat shield, just to keep the heat from going to places it shouldn't do. That's a displacer cylinder in there. Again, it's got to be kept cool, and this here is the cooling chamber, and it's filled with water, obviously. This is your power cylinder, and this is the Ross yoke system. It's quite fascinating to look at. I'm sorry I'm jumping about a bit, but I'm not very stable. There it goes. Very hypnotic. Now, with hot air engines, the most difficult thing to do is to make them run slowly. If you see any of these little Chinese look-alikes, they're very well made, beautiful toys for children basically, but they scream around like an electric drill. Now these are slow. Well, I've made them slow, because if you take them to a show, you don't want a blur, you just want to see the action working. If you've got too much flame on it, I'll turn it down a little bit if I can. Which one does it go? I think that's coming down a bit. This is the piston out of I think it's a Seagull outboard in a stainless steel cylinder. Of course, to make them go slowly, you've got to be pretty well balanced, and that's easier said than done. There's the old water level. Stays cool. What about the water in this one? I can see it in that. Not very clear. I'll put my fingers in. Yeah, they're both the same temperature. This one's going a bit too quickly. Let me turn it down a bit. We'll double the speed if you want to burn the gas. But being as these are going for several hours at a time, you don't want to be burning lots of gas for nothing. Not only that, the more gas you burn, the hotter the engine gets, the hotter the water gets, and in time it will stop. These were on the front cover of Model Engineer. I made quite a lot of hot air engines in my time. They've all appeared on Model Engineering from time to time. That's the biggest one and the heaviest one. Only half finished. I did a lot more work to that afterwards. More cooling towers, more water pumps. There's 4 of my engines sitting in the lounge. If you look up Alan Pickering on Google, you will, not Facebook, on YouTube, you'll see about 70 of my videos. Mostly from my New Orleans jazz band, which I've now disbanded, but there's at least a dozen videos of these engines being made, a picture of the workshop that made them, and an explanation. This particular one here is quite heavy, 75 pound it weighs. That's why I'm not taking it anywhere. There's a plane going over now, there's an airport. This particular engine was inspired. I had a crankshaft off a Villiers 9E motorcycle engine, and I used it and turned it into a hot air engine. Again, water cooled. See if these are still working. Yes, that's the flame. And what you see in there is a flame guard. Not jumping about again. That flame guard, if it's visible, is in fact the lid of a coffee jar. These are very satisfying things to make. For one, they don't have a boiler. You don't have to get them boiler tested. They're 100% safe, there's no pressure in there. And they reward good workmanship. If there's anything that's misaligned, they will not work at all. Most engines, if you stick a feather on the flywheel, you'll stop them. Not too much torque there. Let's have a look, see what this one looks like. There's a little bit of torque in that one. It doesn't want to stop. Incidentally, if I stop this, you can see the balance weights. Difficult engine to balance. And I finished up putting these two extra weights on top of the fixture underneath. It just wasn't enough. There she goes. Everything has to be perfectly aligned. And I mean perfect. And all these bearings that you see going up and down, like this one, this one, this one, this one, they're all got double needle roller bearings in them, and big bearings in the flywheel. The same applies to this engine. All these little moving parts around here, they all have a double row of needle roller bearings in them. And that's the secret of getting them smooth. And as I said before, everything has got to be perfectly lined up. Just one or two thou out and they just don't go round. As I say, they're not easy to make. Well, you think they're easy to make, but when you finish them, 9 out of 10 don't work. And if they do work, they're like electric drills screaming round. Try and slow them up when they stop, which is no good for a show. Anyway, there we go. Give this an outing this Sunday, and hopefully they won't let me down. So this is Alan Pickering signing off. And all these little engines, they go in the back of a Honda Jazz easily. Okay, so that's it then. Cheerio, thanks for watching. Have a look at my other hot air engines on YouTube. Alan Pickering hot air engines search. Thanks for watching. Bye bye.